So this is a beginner workshop, and I'll be using a bunch of different data, but mostly will be supply chain data. Can you see my screen well?
Yes.
Yes.
Okay, perfect. Good. Yeah, and the tools I'm going to be showing you all might not be the usual tool that we see in a supply chain related role, but I think it will help quite a lot. So today we're just going to go through some basic stuff, and we'll end up with an example analysis, just so that you see what the end state kind of look like before we dive into. Sorry, there's another person that want to get in. To get in? Oh, yeah. Okay.
I let them in, Yasin.
Okay. Perfect. Cool. Thank you. Yeah. Just so that you see the end stuff, the end state of what an analysis look like. I think it's important because it's less scary than you think. It's not. Yeah. You'll see, but it's way less scary than you think. I'll reiterate the goal. We're going to go to the prerequisite. So just foundational stuff about what is data science, the tools, why I'm not going to use Excel. You'll see why, and just the general workshop syllabus for the next ones. So if you have any question at any time, just raise your hand and I'll answer them. The goal of the workshop series I'm starting up is just to you have enough data science principle so that you can conduct yourself your own analysis. I'm not going to try to teach you like the whole data science or the whole machine learning or a specific kind of tool. It's more about getting started in order to be able to come up with your own idea and then gather the data and then do it. The thing with data science is that it's very project dependent what you should be using, right? So for instance, if all your data is in I don't know, PDFs, and this is what you have to analyze, well, you're gonna have to figure a way to get the data, and you might need to learn something that you never used before. And then if you ask an experienced data scientist for help, he might not be able to help you because he never got like interacted with that type of data. So it's more about the I'm going to show you a bunch of tools, right? But there's others that you can use, and if you are in a situation where you need to use this other tool, I think it's good that you have the reflex of thinking, well, I'm just going to learn a bit of it, get the job done, and then answer the actual question I started with. So if you already have a knowledge about data science, that might not be the best workshop for you. It's mostly for people that have like absolutely none, that start from zero, not even a programming background. I'm gonna start with this preconception. So if you already have, you can kind of look at the links that I'm gonna post for the more advanced things. But in general, it's for people that know absolutely nothing about data science. If you have an interest for learning how to program, how to set up like a research analysis and then answer like research question, some interest in learning the data science basic and even a bit of machine learning, I think it's the right place for you. Nothing too deep in any of these topics, because we can go into like these are like full blown courses in and of it themselves. Yeah, it's just about being able to get the basic done so that you can learn the whole thing afterward by yourself. So everybody's good with this? Anyone had any question about any point here?
Sounds good.
Cool. Let's do it. Perfect. So what is data science, right? You can ask this question to a lot of people that will have different answers. But in general, like if we look at the Wikipedia definition, it's pretty spot on. It's like it's an interdisciplinary academic field that use statistics, scientific computing, science stuff, algorithm to use the data and get some knowledge out of it. So the data is usually like noisy, like structured, unstructured, depending. But you get data from a source, and then you extract the knowledge at the other end. So the usual step to answer a data science question, it look like this. It's like you understand the question that you're trying to solve for. You collect the data, or like you retrieve the data where it is, and then you explore the data, and at the end you answer the question using the data. Like this step is important because if you don't know what the data is about, you might not see like some error, some pattern that can bias your analysis. So basically, it looked like this, right? In a schematic form, you have a question and you have data, right? And then you put it into the data science machine, and then you're able to get some insights that pertain to the first question. If you have no data, well, yeah, like it's not, you're not going to be able to do data science at all, right? You're gonna have to go to the step 0, which is to collect the data, which is fair enough, right? An actual research project start with this. You have a hypothesis, and then you go in the field, you collect some data, and then you come back and you do your thing. Most of the time, what happens is that you already have some data collected, and you have to deal with it. Maybe sometimes it's not the best type of data that you can have for this specific problem, but that's usually the setup, especially like in a business setting. So when we talk tools, I'm going to present you the tools we will actually learn. So it's these things in these box, right? So you have Python, you have Pandas, Matplotlib, NumPy, which are Python packages. We're going to code our stuff in what we call Google Colab. You'll see why I'm gonna use that. I'm gonna teach you a bit of SQL to get the data, but most of the time, it's nothing fancy that you need over here, right? We're not doing some crazy data engineering type of stuff. It's just like get the data, and then we parse it, and then we manipulate it. Some scikit-learn, and this is for machine learning. It's like the most basic package you can use to analyze your data with machine learning algorithms. And finally, the most important one is your brain. So one by one, why the brain is asking the right question usually, and using the right tool is the most important step. If you're asking the wrong question and using all of the other tools, like it's not going to work. And if you have the right question, but you use like really poor tools, you're going to complicate yourself for nothing, and it's just not going to work. It's going to be too difficult. So like before you start, right, anything, understand what you're looking for to answer your stuff. Don't just make like dashboards and things like that for nothing. If you really want to go into like exploratory data analysis, do that, but know that you're doing this, and then use the right tool for the job. So for instance, if you're at your job, you're using Tableau, and then one of your question is to be able to understand some part of the I don't know, the logistic process. There's a problem in it, and you want to understand why. You might be better off just starting to learn Tableau and then use that, right? Instead of like trying to learn a completely new tool that no one has used in your company and then try to jam it into the workflow. So second super important tool is Python. Python is actually not a tool, it's just a language. So it's one of the most useful, most used language for data science. Just this is it's kind of the sole reason why we're using it. It's used for web development. It's used for server stuff. It's used for a lot of things. But in data science and machine learning in particular, it's pretty widely used. So it's usually best to use something where there's a lot of community behind it, because then when you're gonna have to troubleshoot, the probability that someone else already had the problem is very, very high. So you have less problem to solve, and you have more learning. It might happen that you can't use it for whatever reason. So that was my case when I was doing research. I had to use MATLAB because most of the code I can use was in MATLAB. And it's pretty painful because there was not a lot of help for this my particular set of problems. Yeah, so this is why we're using Python. Okay, now we're getting into like the specific tools for Python. One thing that you have to internalize very, very early on is you don't have to code everything and do everything yourself. You should not be doing this because you will introduce error. So for instance, what I mean is if you have to calculate the mean, you don't have to kind of manipulate the data to calculate the mean yourself. That would be very dumb if your goal was to just calculate the mean. You just use something that will calculate the mean for you, right? And if it's something a bit more complicated, like I want to, I don't know, train a machine learning model to do X, right? Don't code the whole machine learning model from scratch. It has absolutely no use. It has academic use, but it doesn't have a use for your particular project. So this Python package, Pandas, right? It's a package in Python, so it means like it's interconnected with the programming language that you're using. Think of it as an Excel sheet of your analysis. So basically, you can dump data on it, and it has all of the capability to structure that data and allow you to use it programmatically, which is fantastic. So it's always the first thing that you, like usually it's the first thing that you use when you start a data science analysis. And we're going to see it afterward. Second one is NumPy, right? Pretty ubiquitous everywhere, and it's basically the math and like all of the manipulation you have to do on like the pandas data frame, and like most of the stuff are already set up in it. So if you have to do some complicated, I don't know, you have a formula for whatever you want to set up, you can just use NumPy and build this formula with their specific how to say it, building block. Then you can build up your formula. Third Python package is Matplotlib. It's not the best, in my opinion, to make visualization, but it's the most widely used and oldest. And it doesn't matter here. You can swap this with like Seaborn. You can swap this with like other packages that do a visualization. But I feel like this one is good because there's a lot of snippets out there so that you can use it and you can have a good, solid understanding about how to view the summary of your data. And it interconnect pretty well with the other two that we've talked before. The other thing here that we're going to use is Google Colab. I prefer not to work directly in here if I have data on my computer, but like most of the stuff that we're going to use will be data that we find online. This is good because it's like the easiest interactive development environment for data science. It's already preloaded with all of the stuff. So a lot of configuration thing you will be doing if you work on your own computer with your own data, like without internet and stuff. You don't have to do it here. And it's just on the cloud. You can just go to Google Colab, you get a free account, and then you can directly start to analyze stuff. So that's the sole reason we're using that. SQL, this is a language to get data from your database. Basically, that's it. And it's not going to be like complicated, like mega SQL query we're going to be learning about. Even unoptimized ones are good if your job is to get the data and then to process it afterward, right? We're not going to do much of the analyzing and the pre-processing within an SQL query. You could do that. We're going to do it afterward with pandas, NumPy, and all of the other stuff. The last one will be scikit-learn. Scikit-learn is it's a Python package to do the machine learning stuff. So everything that you need to train a model that is not a neural network, scikit-learn is really good at it. It's quite of a well-used library. So if you have to use like model that are more more shallow, like linear regression, principal component analysis. It's always handy to know this one and its syntax, because it's kind of everywhere. Yeah. Any question about the tools that we're gonna use? I know it's a lot of them, but you see, like, in any data science experiment, you're gonna see a few of them always. So it's kind of more the foundational ones for Python. Okay, I think we're good here. Okay, cool. So yeah, why not Excel, right? You could technically do some data science with Excel. However, I think it's a bad idea most of the time, mainly because for three reasons, right? So the data is mixed with the logic. What I mean by that is the Excel is great because it's like a sheet, and then you have your data, and then you can put your rows and stuff. But the problem with this is that well, the data is there, right? But it's not versioned in any way. And if you override something, okay, you can protect some cells and stuff. But like, if you have some logic in order to process the data, it's within your data, which look like a good idea, but it's not. Okay, so the second problem is that the logic is hidden in the cells. So it's not like the logic is a recipe that you can follow along. There's a way of making it work, but then it starts to become complicated. And at this point, why use Excel? And if you have error, it's very difficult to trace back. And all of this problem become even more complicated as the Excel spreadsheet grows and becomes a monster, right? Especially if you have interconnected Excel spreadsheet. At this point, it's a nightmare, right? And Excel is everywhere. As at some point when an Excel spreadsheet becomes a bit too big, it might be better to have it in a more structured format, like data science analysis, that you can actually read from top to bottom and understand the structure and version over time, and it doesn't mix with your data. So that's what I mean by, like, the data is mixed and then everything is messed up. Is there's this concept of model view control, which is prominent in website usually. It's a way of separating these three things so that you don't have to you don't get a mess on your website. So the view is how you visualize the data, right? The data is kind of defined in the model. So in Excel, the model and the view are kind of mixed up together, because when you want to make a plot, you just go clickety-click on the data, and then you're able to view it just next to it, right? That's problematic. In of itself, it's a bit problematic. And then the controller is like the logic. Now, in this case, logic for Excel is directly jammed into the model, which can affect the view, right? In a good data science setup, usually what you want is you completely separate it. The data is on one spot, and then if you have to do manipulation, you can version the data so that you can work with different version of it, right? But like, how you generate plot with the data is kind of like a step at the end that you're done with your logic stuff, and the logic is what you're going to find in the code, literally. So you have this really neat separation between the three, which makes it able to scale much more well and do more complicated thing than Excel can ever could. And it's fine. Like, Excel is good if you want to just start up, you have the data, and then you can just duct tape your analysis. But as soon as you get a bit bigger and that you a bit more complicated, or you work with the other folks, it's usually better that if you're not doing data science with that. So the workshop syllabus, how I want to go about it is, first I'm gonna show you the basic of programming, not in this one because I won't have time, but like in a future workshop. So like I said, very basic things. So how to work around your data and with the programming concept, so with Python. And you'll see Python is like one of the most friendly computer language you can ever have, which is why it's so widely used. After that, some basic of data science. So how to use the 3 tools that we've talked about just before. So NumPy, Pandas, and Matplotlib, so that you can make an actual analysis that hold. And some stuff that you usually want to do in a data science project. There's a kind of flow that you follow. Yeah, so I'm going to teach you that. Some basic SQL. This will be very light. Oh, sorry, I mixed up this one. There's one too much. Not too workshop on SQL, but like SQL, just some light stuff so that you can understand a bit how you need to gather the data. And SQL is made to be super simple. So it's not too complicated, but like it can get very complicated depending on how your data is set up. Some basic of machine learning, nothing too complicated here either. I'm not going to go into theory of it, more of like the high level black boxy stuff, the structure of it. And after that, if you want to go more deeply into like, okay, what model should I use and stuff, there's a whole world to learn on this front. And then some project walkthrough from like start to end with all of these tools that we've learned. So we can maybe go into some example analysis. I think that will be the most efficient way to for you to understand like what the hell I'm talking about right now. And if there's any question, don't hesitate throughout. So yes, I'm still there. So here we're in Kaggle. That's another thing that you might find yourself interacting with, especially if you're doing machine learning. But I'm going to show you like the flow that is usually there when you're doing like what we call EDA. So an exploratory data analysis. You have a bunch of data that you have, right? And maybe it was in your Excel, and then it was a dump from somewhere else. And now you have to do something about it. The very first step that usually a data science project you're doing is that you're exploring the data, right? And you can do that also with Excel. You can look at it. You can look at the different statistic about the stuff. I'm going to show you how it look like when you're in a not Excel format. So the data is as follow. It's a bunch of it's an historic data set about shipment pricing for I think it was vaccine stuff, right? Not too important exactly what it is, because we're not doing we're not answering really any question here. We're just kind of looking at it and try to understand it a bit better. And I think it's vaccine that are sent mainly for I'm not sure where they're sent, but like they're sent in different ways, from with air shipping and then water shipping and road shipping. And then what we want to do is just like to look at it and see how the data is structured. This is usually the first step. So you have your usual stuff, right? Every data science, even machine learning project ever, right? They always have this tabular format, exactly like it's Excel, right? It's just the scale and the way you're using the data that is changing. So you have your rows, which is usually one instance of a data. This is what we call a data point. A row is like a data point, and then you have your column, which are like the feature of that data point. So in this case, it's like one shipment, I believe, that goes from one place to another place, and it has all of these things. If you're working with Excel, you can kind of flip it over and do a bunch of like different thing with it. But usually in a data science project, you want to have it like this. The rows are your instance, and the columns are your features, so the characteristic of your data. Okay, so that's being said, we can go through these few steps. When you're going to go into Google Colab, it will be like this. It will be like what we call a notebook, right? So a notebook is what have your code plus some text if you want to, and plus some some plot, so that you can then give that to somebody else, and then you can go through the whole thing and understand the whole analysis. So the very first thing that you're gonna see always in a data science notebook is the importing of packages, right? No way you're gonna see a data science analysis with like nothing, just some raw Python, and that's it. You're always gonna see this first thing at the top, and this, what it means is that I have a bunch of libraries, right? So code that other people did, and I'm putting them into my notebook so that I can use it. So I don't have to write all of the code myself. That's kind of the idea. So when you're doing that, you're taking all of these libraries and jamming them into your thing so that you can use it. And the format is always the same ish. And in this case, if you read it, like they have pandas, they have NumPy, they have a bunch of other things. They have Matplotlib that they are importing, and then some other kind of library. So Seaborn is a plotting library that they're importing. And then they're doing a bunch of configuration stuff, which is not too important. So that is the kind of stuff that you're going to see. And then usually right after that is when you're going to actually read the file, right? Which contain the data, or maybe sometimes you're actually going to make the SQL query straight into the notebook if you're doing a analysis that always require like some fresh data. So you can have your SQL query, and then you're just going to query it and get the data in tabular format and jam it into your Panda thing. Yeah. So if you look here, they are importing Panda as a PD. I'm going to zoom in a bit. Just a shorthand because they don't want to always write pandas everywhere. They want to write something a bit smaller. And then if you look over here, just this line is enough to read the file that I showed you earlier, this one, right? This Excel spreadsheet is like a comma separated value file, and then put it into the creating it programmatically inside your notebook, right? So you don't drag and drop and put your data here. You literally say, I want to read that file and put it into this variable, which will be now into my notebook, which I can then use and manipulate. So at this point, you have your input in, which is your data. And you see the format is not too complicated in Python. Here they are saying, take the library Panda, take the function read CSV, so read comma separated value file. Here's the file I want, right? And then that's it. And then this thing is just another function that says fill the value with 0 with NA, so not a number. That's it, right? Sorry, fill NA with 0. That's the opposite. And then you take all of this and you put it into the variable data set, and that's it. Like at this point, you have your data set inside your notebook. And if you can do like now, you can manipulate it actually and do something with it. If you want to see it, you see we have the whole thing over here, and it's in code, so we can actually do something about it. Yeah. Any comment here? Like what I'm doing right now, I'm just throwing you all into the deep end so that you can actually see what the end result look like. And then in the other workshop, we're just gonna backtrack and go back to the basics. So if all of this means kind of nothing to you, it's perfect. If it does mean something, you're on the wrong workshop. If it means nothing to you, it's perfect, because that's what we're gonna learn. We're gonna learn what Panda is. We're going to learn what is the syntax to import stuff in Python. And then we're going to build up until we come back to this actual project. So everybody's good?
Yes.
I'll take that as yes. Perfect. Thank you. So you import your data. Yes, go ahead.
No, everything is good. Sorry, I
Okay.
hit the wrong button.
It's fine. Yeah. So now you have the data set over here, right? And then you can have in this variable, right? So when you program something, you have variable and you have function, and then you can do stuff and then store these stuff into variable. Yes. Okay, cool. Thank you. You can store stuff into variable, and once they're in variable, you can manipulate them, right, programmatically to do something with it, and then store them into other variable that means something to you. So that's kind of the workflow. Here, after this, just to talk about like doing something. You have the data set variable you see here, it's the same one, and then we're doing something on it. So in this case, in this particular cell, so this is a cell in a notebook, they're counting the number of data point that we have. So what are they using? A function called len, which is a shorthand for length, and they're counting the lengths of the data set, and then they're putting it to this variable and then displaying it here with a function that is called print, right? So you kind of start to see a bit the syntax when you have this with parentheses. Usually it's like a function that does something, and then function is just like a recipe, right, that somebody else coded. And then with this, you're able to not do a lot of work. So if I wanted to code length, this function, I will have to do a bunch of things that are called for loops, and then keep track of the state, and then iterate on this thing, and then take each of the row and count them manually, put that into a small recipe, and then use it. But because there's already all of these tools that are existing, I don't have to do that. I just have to put all of the tools together in order to answer my question. Same thing for here. I don't have to understand the format of a CSV file now, right? Or whatever other type of file that you might have. You just have to learn the right function within pandas to be able to read that thing and put it programmatically into the exact same format every time, so that you can use it in the rest of your analysis. So that's the power of like having a programmatic workflow like this instead of an Excel workflow. Here you can check the data type of all of these things. So data type is another programmatic stuff that you might come about. But if you're using Excel for like basic analysis, you went through this anyway. There's stuff that are called numbers, so integers, floating numbers, and there are stuff that are like text, so string. And then these things, you can't do math on them, but like integer and float, you can. So that's kind of one thing that you see here, and it's easy because with Panda, you have all of these functions to query the thing in order to know it directly. With Excel, you have to kind of dig a bit through it to be able to know. So here we're able to see like all of the different row into the all of the different column in a specific data point. So there's a bunch of features. There's the ID, right, which I believe it comes from, let's say, if it was in your ERP system, this was the first ID for this specific vaccine kind of shipment data set. And then it need to be unique, I believe. And then you have the project codes, some PO numbers, the country that it was shipped to, the shipment mode that it was shipped to, the brand, the dosage that it was in it, the pack price, the unit price, a bunch of stuff that now you know that you have that, you'll be able to think a bit more about what you can do with it. Let's say you had a question, a data science question that was, I want to calculate the price per pack over time of a specific dose sent to Vietnam, right? Well, first take a look at your data, and then do you have the required information? If you didn't have the dosage information and the country information, only the pack price, you can't do it, right? You have to go back, either collect the data or figure a way to interpolate it with the rest of the data that you have in your system. So this is why it's important at first to do what this notebook is all about, which is exploratory data analysis, which is to look at what you have and then to check if you can answer a specific question. And then here there's other different type of function that you have in a Panda data frame. You can call head over here with the number, and it will give you the first X row. So then you have 10 rows over here. You can have like, hey, I just want the first 2 rows, 3 rows, let's say, and then you can get the 3 rows over here, look at them a bit more in details, and look at the actual numbers that you have here. It's useful usually for debugging and to check if you have the data in the right format. Yeah. Then you have tail. It's the same idea, but like at the end of it. And these type of function, I'm going to talk it a bit more when we're in the basic of data science kind of workshop, because there's a few of them that you just have to know. But if you don't know all of them, it's also not a problem. Usually the workflow is like you learn them, right? And then when you get to a problem or like a spot into your data science project where you're like, I need to see the last 4 row into my data frame. You just Google it quickly, and then you're usually going to get an answer pretty fast, because other people try to do that thing. So now we're going to check out the kind of the very first type of graph that you'll ever see in a data science notebook like this. And you see it's not that complicated to generate a graph that is kind of good looking. So here, what this notebook wants to do is like do the total 10 country wise count. I believe per, okay, they want to group per country and then count the number of shipments. So basically they want to count the number of shipment that was sent per country for the top 10. That's the idea. If you look at it, the top 10 country are these ones. So South Africa is the top first, and then Tanzania is like the 10th. And then there's other country that we don't see that are there, but this is the top 10. If we break down the code, there's not too much happening, right? It looked like a lot, but it's not. So let me just break it down a bit here. So first, here, this is just like some pre-processing that we're doing. And if you see, I'm writing right now, but this is a comment. So a comment in a code is not actually run by the whatever programming language you're using. So this is Python. It will not run this. I just a note I'm leaving to myself. So here, this is the part where you're doing pre-processing. So you have your Panda data frame, and you do this function, which is drop all of the not value. So stuff that are just not filled up, which you will have. If you're working with real data, sometime a user didn't fill up something. So you have to do those kind of cleaning before you can actually do something about it. So why? Let's say you're trying to calculate the mean of something, and then half of the value are like emojis. How do you calculate the mean of that, right? So you have to take a decision. Either you can interpolate them, or you can just drop them and calculate the mean only with the filled up value. So it was actually a pretty bad example, but I think you get the gist of it. After that, you see over here, we're chaining a bunch of function, right, on a data frame in order to kind of do the movement of chopping and then grouping stuff together in order to then do the analysis, right? So here, what they're doing is that in the whole thing, right, in the whole data frame, they're only gonna keep the country, right? So the country kind of row. So if I actually show it to you like this, there's just this thing. If I show it here, just this thing, we went from the full data set to just a row and one column, because we index into that data set, and then we just take the column country, right? And then there's a bunch of them. And then here, what we're doing is there's a function in pandas which is counting the value, right? The value that are grouped together. So what it means here is that it will look at Zimbabwe, and then it will count all of the Zimbabwe together. So if we chain that over here, get that. You see South Africa is the top, then you have Nigeria, and then the last one is kind of like Guinea. You have one, right? And then here what we try to do is get the top 10 countries. So, and there's another function that is called n largest, and then you just get the n largest, and then you decide how much largest you want. And here in this case, it's 10, and then you get those 10, right? That chaining of operation give us the item counts that we needed. So kind of if you know the function roughly what they do, and then it's easy to interpolate it because the function are actually made so that you can read them and kind of understand it. But if you ever don't know, and you're in a new in a new thing, there's always documentation online, right? And then you can see, okay, the panda value count, what they're doing is return something containing count of unique value. Okay, so if you see somewhere, you can kind of know what it does, but there's no better way than just actually using it. Here, we're printing a bunch of stuff to the screen. So we're saying top 10 country-wise count. And if you look here, this is it, top 10 country-wise count. And then they're printing the exact same thing as I printed above, over here. And then this is where plotting. So when you create a plot in like a programmatically with like in data science, like even with like Python, Python, MATLAB, or whatnot, R, if you're using R ever, they always kind of have the same format. And it's you use a library, you get you create the figure, and then you put the plot in the figure, and then you add the stuff around. So the title, the X label, the Y label, you can modify how it look like, but it's kind of always the same kind of stuff. So here in this case, they're using Seaborn, and Seaborn is just like another tool like Matplotlib. So it's kind of the same thing. And you can, if you see a block of text of code like this, usually you can just kind of stop and say, okay, this is a figure, and this figure is creating this. So if we break it down, it kind of look more like that, right? Here, they're just setting how it will look like, right? And you can look at the function, but it just kind of what's the color looking like. Here, you're saying what's the figure size I want, and I want to create a figure, right? And at this point, is like, okay, what's type of plot I want, and what's the data, and then you just plug it at the right spot. And here is just some cosmetic change that you're doing to put this text here, and this text here, right? So if you chunk it down a bit, you'll see what it means. And if you get that snippet somewhere, always try to understand what each part is doing, because then you'll be able to kind of modify it as you please. So that's like you'll see, we're just gonna come back again with like kind of the same setup. In this workshop, we're not gonna use Seaborn, we're just gonna use Matplotlib. Because I feel it's a bit easier than Seaborn in terms of usage. It's a bit more ugly, but it's a bit easier. Yeah. Any question until now? Right now, you should all feel a bit lost in terms of like the stuff. It should feel a bit more complicated. Cool. We'll go through the notebook, and then I think we'll be done for this one. And I'll be able to give you a bit of context about where you should get some more information about each of the stuff. But in the next workshop, we're going to go straight to the programming aspect of it. So here, same thing. They're trying to get the pack price for the top 15 country. So you should start to see kind of a pattern, right? You see, it's the same thing. There's some pre-processing we're doing to put the data in shape. Here they're doing a bunch of printing, and then this is the plotting kind of section of the code, and it's the same kind of format that they're reusing again and again. And if you see here, n largest, they put it to 15 because this is what they're trying to do, and they're keeping the country and then the pack price, and then that's kind of what's happening here, right? They're grouping first by country, and then they're taking the pack price, and then they're summing it up, taking the n largest, and with this total price per country for the pack price, they're able to make the plot, and they kind of look like this. So this is the top 15 country in terms of pack price. You have 25K over here, and then this one is the first one, Nigeria, and the last one is the 15th one is Guyana. I don't know how to spell it. So if we look at another part, here in this case, they're checking what they call first line. So it's a feature that they have, and they want to see like how much yes and no they have, and they're just making a bar plot out of it, right? And still, you see it's the same kind of setup. In this case, you don't have to do much, so they just directly kind of plot it. This part, actually, they could have put it as a variable and plug it here like this. Line designation wise count. You do that, and then you can replace this over here. Should be good to go. It should work still. It works still because here I've done the calculation before, so the pre-processing put it into a variable, and then I'm able to put it and input it into this function, which is count plot, which is making this plot over here, right? So if you were using Seaborn, whatever you're working, learn the Seaborn syntax. If you're using Matplotlib, learn the Matplotlib syntax. But it kind of doesn't matter. You just need to know the interface to it, and then you can use it. Yeah. The other type of analysis they're doing, they're looking at the shipment mode and how it's structured depending on with the whole data set. And then with that, they're able to see like, okay, so 59% is air, and then we have 27 in truck, right? And this wasn't difficult to do. They just need to use the same building block we saw earlier, do a bunch of pre-processing, and then here, this is where they actually do the plotting on this whole thing. They're doing the plotting here in a special kind of format, but it's still the same kind of format of plotting this into a pie chart. Here you see there's a 0. It's most likely due because of NA, so not a number thing. So things that were garbage, and then they just replaced it by 0 like we did at the top. So that's why you see here, maybe the label was not well entered, or there was no label. Yeah, so here 3.49% have no label. And if this is business critical for your organization, that to have label, well, 3.49 of your shipment don't have them in your data. So figure out why is a worthwhile kind of data science question that you can ask, and then you can dig a bit deeper here. So this will be one of the first kind of data science question that you can get out of an exploratory data analysis like this. Here they're just getting some unique manufacturing site names, so they can just print the whole thing, and then they can look at them like the Meditab, Dama in, this one is in the US and stuff. So you can manipulate your data and get some insight out of it. Here they're doing some basic math to get the min, max, and the mean of the shipment mode. So the max air shipment mode is 1,000. Here it's 1. I think it's like K or dollars. And the mean is like 82. So 82, whatever it means, is you get a rough idea about the information. And if some numbers here don't make sense, let's say the min, impossible, it costs $1 to ship something, there may be an issue here, right, with your data. So you have to, another question is like, how much of my data that I have don't make any sense in terms of shipping pack price. And if the minimum pack price should be like $10 and you have a lot less than 10, there might be something else. Maybe they're mislabeled as air and it was actually truck. Yeah. So more graphing. So top 10 manufacturing site. I think this was for all shipment modes. So everything bundled together. What's the top 10? You see, there's India is the best manufacturing site. This is where most of the data come from, and then they just go down. But there's a high tail, a high head over here, and you can do the same thing by splitting it for air. and then you get the same kind of idea, but like with the air shipping, and it's still this plant in India is the best one. Yeah, it's kind of stuff that you can do here. It's not nothing too complicated, but like this first part of being able to take your data, splitting it up in different ways, and then showing stuff is very important. And if you were to do that in Excel, it will have rapidly become like multiple sheets and multiple plots set up differently and multiple versions of the same data. In this case, it's always the same, right? The data source is over here. Right, the data source was left unchanged. It's the SCMS delivery history dataset.csv. It was left untouched. So this data is clean, and then you put it into a dataset variable, a panda data frame, and then you manipulate in two different ways, and then you plot it, right? If there's a bug into how you did something, right? You thought you were doing X, but you didn't actually because the analysis is flawed. You can go through the formula and look at it, and it's a specific section of it, so it's fine. It's easier to spot mistake like this. It's easier to redo plots also without changing a lot of stuff. So for instance, if you did heavy data processing in order to get to the end result of your data, to be able to generate the plot, and then someone said, hey, could you do this for like 20 more? Instead of replicating your sheet and then working on this, you just have to change a few variables, and then you should be good to go. So that's it. That's kind of how it looked like over here. There's not much to it. Like the data science analysis is not in Python with all of these packages is not more complex than other things in life, right? It's just like a different way of thinking about it. And you see there's always segregation of like, there's the data, I manipulate it, I plot it, I do something with it, and it's very formulaic. But as soon as you know these syntax and this way of thinking about the problem set, it's a much cleaner way than, let's say, Excel or tools that are not made really for heavy data science. So next workshop, we're going to start with the basic of programming. I'm going to shoot you up this recording so that you can watch over it. If you didn't understand, I can put you a bunch of link. But that's basically it. So we're going to check out the basic of programming next time. All right. So see you all next time. I'll send you the recording.
Thank you.
Thank you, Yassine.